Okay, so there's a new thing that we call the horizontal line test, and the horizontal line test passes if every horizontal line intersects the graph at most once. Now recall we needed the vertical line test to have a function because each input has to have exactly one output. Now the horizontal line test is what we're going to need in order for the flipped picture to be a function. So again, vertical line test to have a function, and we want prior to flipping the horizontal line test so that the flipped picture would be a function. So what we're interested in, what we're after right now is we're interested in functions where the flipped picture also corresponds to a function. So we're going to want both the vertical line test and the horizontal line test to pass. So let's take a look at some functions and see what happens. We're going to take f of x equals 3x plus 2, and we'll do a little demo here. We're going to draw y equals 3x plus 2. Of course, that's a y equals mx plus b. It's a line. So we'll draw this on transparency. We'll draw this line, 3x plus 2 on transparency. We'll see that the vertical line test passes pre-flip. It should, because we have a function. Also, because the horizontal line test passes pre-flip, the vertical line test passes post-flip. So let's go take a look at that. So we're going to draw here y is equal to 3x plus 2. It's a line that looks like that. Yeah, so y-intercept here of 2. Okay, so the vertical line test passes. That's expected for a function anyway. Okay, the horizontal line test also passes. So wherever you draw a horizontal line, the horizontal line will only go through this graph shown here in one location. And that means that in the diagonally flipped picture, then the vertical line test passes everywhere. Yeah, so since the horizontal line test passes here, the vertical line test passes there. And this picture, oh yeah, this is also a line, but it's the graph of a new function. And so this means that both the pre-flip and the post-flip are graphs of functions. Let's take a look at another one. Let's look at f of x is equal to 2 to the x. Now this is a function we haven't seen before in this class, but we'll just draw a chart of x and y values. Yeah, so 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4. You should try this. You should try plugging in the values of x here on your own. So what's 2 to the 4th? What's 2 to the 3rd? What's 2 to the 2nd? Get your y values. In fact, this is really good practice with eventually you'll see 0 as an exponent. You'll see negative numbers as an exponent. You know what, for instance, is 2 to the negative 4th? This is a good review of some exponent stuff from early on in the semester of what happens when you have a negative exponent. So pause the video, try it on your own. You should end up with these numbers here. Then it'll be important to draw these points, 4, 16, 3, 8, and so on, fairly carefully on paper. Try it on your own. You'll notice, first of all, don't get tripped up too much that the y coordinates are these fractions. It just means that as x becomes more negative, the y value is tiny. It's still close to 0 though, right? And notice that all these y values are positive. This tends to trip people. But we're going to draw this on transparency, and we will notice a couple things by doing this. So first off, let's draw a picture. So we're back in the pre-flip setting. It says graph of f, the original down here. The graph ends up actually looking like this, with a y-intercept here being of 1. Now you'll notice that the vertical line test passes, but that was expected for every function. In addition, the horizontal line test passes. So wherever you draw a horizontal line, it goes through the graph once, or maybe down here a horizontal line doesn't go through the graph at all. Okay, if we flip diagonally, now because the horizontal line test passes this way, that means the vertical line test passes here. And we see every vertical line either goes through this graph shown here once or not at all. And so that means this is the picture of a function. So this function here, there's a picture of a function. Once you flip, we get a new function. Okay, so both the pre-flip and the post-flip, these are both pictures of functions. They're both graphs of functions. Okay, let's try another one. Let's take a look at f of x equals x squared. Okay, so we know this graph. Yeah, it's the standard friendly parabola. So let's go ahead and go back to here, and we'll draw. Yeah, so y equals x squared. Standard parabola looks like this. Okay, so now, the vertical line test passes, as we expect to occur for the graph of any function, but the horizontal line test fails, and this means once you flip, this here is not the graph of a function, right? Because here the vertical line test fails. Here, pre-flip, the horizontal line test failed. Therefore, post-flip, the vertical line test failed. And so this is not the graph of a function. However, back in the pre-flip setting, this is the graph of a function. All right, so here we have our first example really of in the pre-flip setting, vertical line test passes and therefore you have a function. But since the horizontal line test fails in the pre-flip setting, the vertical line test fails in the post-flip setting. So while the pre-flip, which passes vertical line test, is the graph of a function, the post-flip picture, which fails the vertical line test, is not the graph of a function.